Welcome to EDU World Space.
Problem 3.129. In this problem, four forces are acting on the signboard and we have to replace these four forces by a single equivalent force, and we have to find magnitude of that single equivalent force and its point of application. So first of all, let us try to draw the equivalent force system. So let us say that this was our signboard and this is A, B, C and D, and our force, that is equivalent force, is acting here, and that is of magnitude R, and it's since this axis is given as x-axis, this axis is y-axis, and perpendicular to this is z-axis. So B is the origin. Here also B will be our origin as it is indicated in the problem. And let us say that this coordinate, since this will be in xy plane, so its z coordinate will be 0, and let's say that point of application is for example here M, and whose coordinate is going to be x, y, 0. It means that it is at a distance x from side AB along the x-axis and at a depth of y from the member BC. So we can say this distance is going to be x and this distance is going to be y. So first of all, we will balance the forces along the z direction to get the magnitude of this equivalent force. For that, we will equate the forces in z direction. So this R is acting in negative z direction, so we can write it as minus R, and that should be equals to, since all the forces are in k cap, so we need not to worry about the vector direction. We only have to see its value, that is we can also go for the magnitude. So we can go directly for the magnitude. So I'm considering here the force to be in negative direction, since all of these forces are acting in negative z. So I'm here also consider the equivalent force to be in negative z direction. So we have to only worry about the magnitude of the force. So we can add up all those forces that are acting here, since they are all parallel to each other. So we can write it as 105 pound plus 90 pound plus 160 pound plus 50 pound. So the equivalent force comes out to be, if we add up these, 405 pound. Alright, so now we have got the magnitude of the resultant force. Now we have to calculate the value of x and y. So to get the value of x, we can balance moment about y-axis, since x is going to be distance from y-axis. So if we balance moments about y-axis, so moment about y-axis in equivalent diagram will be r multiplied by x, and that should be equals to, if we see here, this 90 pound force will have a distance of 2 feet from y-axis, so its moment will be 2 multiplied by 90. This 105 pound force will have a distance 5.5 feet from y-axis, so its moment will be plus 105 multiplied by 5.5. This 106 pound force will have a distance of 5.5 plus 9 feet, so we can write its moment as force multiplied by perpendicular distance, that is 9 plus 5.5, which will be 14.5. Alright, and the fourth force that is acting here is 50 pound, and moment because of that will be force multiplied by perpendicular distance, since this distance was 14.5 and this will 8 feet will add in them, and it will comes out to be 22.5. So in this equation the only unknown is x, since r we have just calculated above. So value of r x comes out to be 12.60 feet. Now to get the value of y, since y is the distance in xy plane from the x-axis, so for the calculation of y, we can balance moment about x-axis. So if we balance moment about x-axis, in equivalent diagram, the moment will be r multiplied by y, which comes out to be in actual diagram. If we calculate moment about x-axis, so this 105 pound force will have a distance of 5 feet. So its moment will be 105 multiplied by 5. This 90 pound force, since I'm considering here the depth direction to be positive direction, so I have written here plus y. Since this force 90 pound is acting above the line BC, rest all are acting downside, so all of them will cause the same sign of moment, but this 90 pound is going to cause opposite sign of moment. That's why the moment because of this 90 pound will be minus 90 multiplied by its perpendicular distance from the x-axis, and that is here 1 feet. So multiplied by 1, now plus 160 pound is again in the downward direction to the x-axis, so it will be plus 160 multiplied by its perpendicular distance, and perpendicular distance here is 3 feet, so multiplied by 3. And for the 50 pound force, this will be plus 50 since it is also in the downward direction, and its perpendicular distance is 5 feet, so multiplied by 5. So again in this equation, the only unknown is y, since value of r is already known, that is 405. So value of y comes out to be 2 minus 2.94 feet. So I have considered here the value of y to be positive in the downward direction. It means that this will be depth from the member BC. So we can finally write our answer as the equivalent force of magnitude its magnitude was 405 pound will act at 12.60 feet right to the member AB and 2.94 feet downward to the member BC. Right, so this is the final answer.